Quicksort is the most commonly used sorting algorithm. The idea is to grab the last number, we call it pivot, and put it in its correct place. Wait, how? Well, if you move smaller numbers in front of our pivot and larger numbers behind our pivot must be in its correct place. Okay, but the smaller and larger numbers are still unsorted. Yes, they are, but we will recursively call quicksort on the smaller and bigger part, and we stop when we have at most one number in our part. So let me show you an example. Okay, I got here an array, and this algorithm says we grab a pivot, which is last number in our array. In this case, 8. And as I said before, we want the smaller numbers to be on left side and the bigger numbers to be on the right side. So we got this wall, which represents the splitter between left and right side, and also pointer, which indicates what number are we currently comparing. So we compare a pointed number with pivot. If it is smaller, we swap it with first number behind our wall and move our wall by one number. If it is bigger, we just move on to next number. So let's do this. 2 is smaller than 8, so we swap it with first number behind our wall, but in this case 2 is already first number behind our wall, so we just move the wall by one number. 5 is smaller than 8, so we swap it with first number behind our wall, but once again 5 is already first number behind our wall, so we just move the wall. We continue comparing 20 to our pivot. Well, 20 is bigger, so as algorithm says, we move on to next number. 15 is also bigger, so once again we move on. 1 is obviously smaller than our pivot, so we swap it with first number behind our wall, in this case 20, and move our wall. Wait, 5 and 1 are clearly in incorrect order. Yes, they are, but they are both smaller than our pivot, and that is all that we care about. We continue by comparing 11 to our pivot. Well, 11 is bigger, so we move on. Now we know that on the left side of our wall are numbers that are smaller than our pivot, and on the right side there are bigger numbers. So where we should put our pivot? Well, it should be where the wall is, right? So we swap the pivot with first number behind our wall, and that means our pivot is in correct place. Now we recursively call quicksort on left and right side. Let's take care on the left side first. We take the last number as our pivot, in this case 1, and we do the same trick as before. So we compare 2 and our pivot. We see that 2 is bigger, so we move on, and compare 5 with 1. Once again, 5 is bigger, so we move on, and we have reached our pivot. So once again we swap it with first number behind our wall, in this case 2. Now we know that 1 is in its correct place. Let's do the same to the right part. 15 is our pivot. We compare it to 20. 20 is bigger, so we move on to 11. 11 is smaller, so we swap it with first number behind our wall and move our wall. Once again, we have reached the end. Let's put our pivot in its correct place by swapping it with 20. Now we know that 15 is also in its correct place. So we recursively call quicksort on left and right side of our pivots. Once again, let's take care of the left side first. Let's pick our pivot, in this case 2, and compare it to 5. 5 is bigger, so we do nothing. And once again, we have to put our pivot in its correct place. And we will do that by swapping 2 and 5. Now we know that 2 is in its correct place. So let's take care of the other recursive calls. We see that the other two recursive calls have only one number. That means that they are in its correct place. Where else they should be? So the last thing we have to do is recursively call quicksort on 5, but since it is just one number, the same condition will take place.